for having. Um, so yeah, as our introduction also mentioned, so we are not really researchers that work in acquisition, and the app that we'll be talking about is largely a data management and data processing app, and we're trying to explore how this could be used in acquisition studies. So we talked to Benu, one of our colleagues, and we talked to her a lot on how acquisition studies are done, what are the kind of things that we do. But what we would also be looking forward to in this presentation is, a lot of discussion and a lot of questions from your side, a lot of comments from your side as to uh, what we could probably do more, what we could do differently, and what would be the kind of things that would probably be greater support for researchers working in language acquisition. So that's the main idea. And so I'll start with little background about why and how the app came into being. And then Karthik will take over and he'll give you a demo of the app and talk about the features, different features and characteristics of the app. Okay, so Karthik, I think I lost the screen. Should I share my screen?
Yes, I think we can't see the screen right now. Now we can.
Yeah, no. Okay. Okay, so yeah, also so I think we would begin with acknowledging that this is not something that we have done all alone, and there are a lot of people who are involved in building the app. Foremost among them is, of course, Siddharth, who is the lead developer for the app. And so along with Siddharth, Saurav, Aryan, and Neerav, these are three people who have worked a lot on building what you see today as the app. Okay, let's move to the next slide, Karthik. Okay, so why this uh, matters now? Why this app has certain? So we have been working on this for the last 5 years now. So a little under 5 years. Uh, when we started and when Siddharth and I essentially started working on this app. But in the last 5 years, things have changed a lot uh, across, I mean, at least in the language technology side of things. Uh, Probably things have changed all over because of the changes in the technology field. So also in general, I think over the since the advent of the computers, there have been this rise in the amount of data that one could work with. So the volume of data has kind of increased, and it has been increasing ever since, right? And in the last 5 years, what you also see is what one could call AI revolution, and or in the mid, we are in the middle of that revolution. So which there are tools and there are models, there are technologies that could help you in processing large amount of data pretty quickly. Now, there have been apps and tools all along, I mean, before this as well, but they were never so accurate as it is at this point of time. And it was probably never more attractive to work with those things, those apps than it has been now. There's also greater amount of infrastructure support available in terms of not only hardware capabilities, of course, that has increased a lot, so you could run a lot more processes on the system, but also in terms of, say, things like bandwidth availability, internet availability. So those are the kind of things that allows us to collaborate for research more efficiently and uh, with greater number of people. So all of these different developments have contributed to the development of the app as it is today. So uh, it's only within this context that an app like MatraLab would probably work, and we'll see why I'm saying this, but it's only in this context that we could think of something like this to be a practical solution. Next slide, please, Karthik. Okay, so what we think, and this is what I've seen outsider's view about what would be helpful for the acquisition researchers, and I'm sure that this will be probably or most likely very different for people who are actually working on this acquisitions for researchers like you. But what we think could help acquisition researchers is things like accelerated analysis. So, the time that it takes from data to final analysis. So, collecting data to analysis, there is this big chunk of time that goes into processing it. We think that if that could be accelerated, the pace of research itself could be accelerated several times, probably. Then there is things like ability to work with multimodal data. This might sound trivial, but this is not really trivial, because not long ago working with multimodal data was very, very difficult. So collecting it was not probably that difficult, but processing huge amounts of video data, for example, on your local system, or even if you're trying to work with an online app, then uploading huge amounts of data on the internet with the limited bandwidth that we used to have was a big hurdle, a big challenge. But this, if you have multimodal data and you could work with it today in a much easier way, then that provides an opportunity to probably ask newer kinds of questions. And also, of course, large data sets. And this, I think, is true for every subfield of linguistics, where if you have large data sets, that will enable cross-linguistic and cross-site comparisons and comparative studies to help in understanding some of the things that's not possible to understand just by studying one language. Right, so those are the three opportunities that we hope to provide to the acquisition researchers as well. Next question, next slide. Okay, so now what are so that was the opportunity. That's something, those are things that we have now, but we still grapple with some barriers, right? So the first major barrier is, of course, the models. So whenever we are talking about models, consider them as the automated systems that processes the language. So they are very limited in number. So out of the 7,000 plus languages that we have in the world today, for something like ASR, automatic speech recognition, only about 15% of languages are covered. Now, and there's also this thing that all of those languages are not supported equally well. So for some languages like English, for example, or a couple of other European languages, Chinese, these models work very well, almost at par with the with humans. And uh, but for some of the other languages, or most of the other languages, the performance is not really great. And for a lot of languages, the performance is so low that they cannot be deployed in the practical scenarios with any significant gains. So unless and until the models help you in completing your data processing tasks in time that in lesser time than it takes for you to do it manually, it's basically not of much use. Right, on the other side of the things, so this is what um we find in one of the papers, and the recent papers by Kidd and Garcia, which talks about the linguistic diversity in child language acquisition research. So based on that, what we the paper directly mentions that only 1.5% of the world's languages have been studied in in child language acquisition. And so essentially, so child language research and data sets are probably even more scarce than uh, say adult language data, which is used for training these ASR models that I just mentioned. In the context of Indian languages, then there are only 10 languages. Again, we are on acquisition research, so there are only 10 languages that we saw in the list that were represented, and that those 10 languages belong to just two language families out of the six that exist in India or Indian subcontinent. So that's a huge gap, and we would like to believe that part of this lack of sufficient research in a large number of languages is the amount of effort that it takes to process the acquisition data, man, which is generally huge in number and not easy to do quickly. So uh, we could probably hope to have the app that Master Lab that we'll talk about is to fill some of this gap. Uh, Hopefully, it will fill some of those gaps. Okay, next slide, Karthik. The second barrier, and this is the barrier in using the models that are already available. So I mentioned that there are ASR models for 15% of the languages. For most of the models, they are not readily available as easy to use interfaces, right? So one needs to fiddle with uh, command line interfaces, with setting up the GPUs, creating, trying to understand what model checkpoints are, for example, and how to use the models. So setting up the system itself is a huge task, requires a lot of technical knowledge. And then, of course, the documentation is not always up to the mark. So there are not very good guidebooks available. I mean, in fact, most of the time when models are released, it's assumed that they'll be used by other researchers in language technologies and not people who are, who are not working in the field. So those uh, prove prove to be a huge barrier, in fact, even if the models become available. So for the languages, so this is the second barrier that we are trying to again handle by building an UI, a user interface that gives access to the latest models and in a large number of languages. I mean, all the models that are all available for use should ideally be accessible through this UI. Next slide, please, Karthik. Okay, the third barrier then. So if you have the model, if it becomes accessible, then uh, any given model does not work equally well for all kinds of data. So, for example, there are models that will work very well for studio recorded adult speech, but for spontaneous child language, it just fails completely. Right, so also models which are trained on say more formal speech, less conversational speech, and less interactive speech, they don't work really well with uh, natural interactions, as you would say. There are other issues as well. So for example, if the data that you are trying to process has a lot of background noise or a lot of overlapping speech, uh, if it has code switching, um, then it becomes difficult for the models to work out of the box. However, there is always a way to fine tune those existing models uh, with little amount of data so that they become better with the specific kind of data that one is working with. Right. So, and this is something that also requires, in general, would require a complete understanding of how to train the model, how to fine tune the model. We're trying to partially overcome this by providing a no code interface for fine tuning the models. This might still require a little bit of understanding of how fine tuning works, but we hope that that might still help in, there's this uh, click and play interface that one could use for fine tuning. And we hope that that will help in uh, resolving some of the model adaptability issues. So we'll just talk a little bit about the model adaptability a little bit more, because what we think biggest issue at this point that you would probably encounter while processing child language data is this third barrier of model adaptability, which is fact that you will have access to the models, a large number of languages that people are working currently have some kind of models for processing the data, but they may not work very well. So we just did a very small experiment to understand how well or how badly the model performs, and so that you have an idea about uh, what to expect. All these experiments were done on Hindi models, and the model that was used for automatic transcriptions is the model released by AI for Bharat, very recent models, and this is uh, the best. So this is the best model in the sense that the it's claimed to be the best model by the researchers, and on the benchmark data sets, they have proven to be pretty good. So the we did the experiments on a variety of data. Now, the we're trying to understand that how well that model adapts to different kinds of data, right? So how well it works for different kinds of data. So we did the experiments with lot of varieties of Hindi that's spoken by the adults. So, for example, uh, so these are non-native Hindi varieties that we were testing on. So, Bangla speakers is speaking Hindi, Galo speakers is speaking Hindi. So, Galo is a Tibeto-Burman language. Both Galo and Nishi are Tibeto-Burman languages. Bangla is as you know, Indo-Aryan, and Tamil is a Dravidian language. So, we're looking at across different language families and how non-native Hindi could be automatic. So, how does ASR models perform on those? And then we also tested on child language data. And again, child language was this the children were native speakers of Hindi. And but uh, as you'd see that that's not adult data, that's child data. And so next slide, Karthik. So this is what broadly the results uh, are. And as you'd see that for most of the varieties, not even non-native varieties, the model performance is uh, kind of okay. So it varies. Of course, it varies, and it varies a lot actually. So, for example, if you look at PM Modi's speech, and uh, so the model itself is trained a lot on Prime Minister's speech, so it's expected to perform good for that. Still, the word error rate, because the speech that we took for this experiment was I think was an election rally speech with lot of background noise and lot of overlapping from the audience, from the crowd. So all of that was there, and still the model managed to get a performance which was not very bad. So an error rate of 21.49 is 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 generally pretty good. So which is in comparison to, if you look at the first one, that's our benchmark, in the sense that this is the inter-transcriber agreement that we got for Hindi transcription, and which is 12, and that's the amount of disagreement between two transcribers. And we would expect the machines to be slightly better than uh, not slightly better, but to achieve performance which is equivalent to this. Now, then if you look at the uh, other varieties such as the the Hindi spoken by the Bangla speakers or by Galway speakers, you see that there is a uh, drop in performance. So lower the word error rate, the better the model is. So as these bars go higher up, that means that the model has performed worse for those kind of data. And if you look at the data of a 5 years old child, you'll see that it's almost uh, the performance of the model is almost similar to that of uh, non-native Hindi speaker of Nishi, right? And however, what is really disheartening to see is the fact that if you try to process the child language data of a 2-year-old child, the model completely fails in that. So the word error rate goes beyond 100, which essentially means that it even fails to recognize that there is human speech and at several places. So if you're trying to process this kind of data, if you're trying to process data of very small children, then the model will not work as well as it has been claimed to work for adult language. And we think this is a real problem because, uh, I mean, it's especially when you're working with acquisition data, we really cannot say that you start working when the child is 5 year old or older. So a lot of the, but of course, the in between 2 to 5 years old, you'll notice that the model has improved. But now, what our proposal in this case would be to how probably could our app help in this scenario is by allowing you to fine tune the model on your own data set. So we could, if you have access to the data of 2-year-old children, maybe you could manually transcribe couple of hours or say 4 hours, 5 hours, to the 10 hours of data, and then use that to fine tune the existing model. The performance will definitely improve manifold and you'd be able to use that data. So that's the proposal at this point. Next slide, Karthik. Okay, so we also ran a little bit of qualitative error analysis, and most of the time, so on all of this data, so these are the four major um, patterns or scenarios where the model doesn't perform very well, right? So developmental speech, which is the child language data, and of course if there are a lot of speaker overlap, if there is a lot of background noise, and also in cases of code switching and mixing, the models don't perform well. And these are the exact scenarios where we think that fine-tuning models on the specific data sets would help in improving the models. And probably, so if you work manually with 10 hours of data and you have to process, say, 200 hours of data or 100 hours of data, it still accelerate uh, uh, a lot of things down the line. Next slide, please, Karan. Okay, so I think now it's Karthik's turn. So what Karthik will basically talk about is the app and how he'll go up to the fine-tuning part and how the things that could be done using this.
Yes, thank you, Yangchen, for inviting us, and thank you, Ritesh, for setting the stage up. So, what we are going to, what Ritesh discussed so far, are the issues in adapting AI models to solve the transcription bottleneck. And we did a small experiment, and then we showed you what those results are. So, all this work where done within our software suite called Life. And within Life, there are at least two major softwares. One of them is called Ateco, the other is MatraLab. We would be also introducing, probably for the first time, about the Life Model Studio, that is auto-train fine-tuning facility that Ritesh just pointed out. So we'll first start with Life and MatraLab, then Ateco and MatraLab, and then I'll move generally as the talk progresses into fine-tuning and stuff like that. Now, the motive of developing the app, as Ritesh pointed out, is to see how we can harness the AI's ability to help us do better. So we wanted something that could be auditable, that is transparent. That's the first thing. We wanted something that is trainable, and we wanted something that is accessible. So now, to begin with, to make it accessible, all the things that you're going to see, as you can see on the right side of your screen, are a no-code platform. So we don't have any code in any of the solutions in any of the places that you see here. And then once we produce this accessible platform, we want to make that adaptable, and then we also want to make sure that it is transparent throughout the process. So that's the major thing that guides our design or design philosophy. Now, the system architecture overview. So this is just what are all the stack system software stacks that we use to build the model, and what also powers our AI engines. Now we have a front-end layer, which is HTML, CSS, JavaScript, and indexed by a DB for local storage. It's responsive and it's up to the date. Now, what we find at the backend is Python Fast API, and served via Flask and MongoDB as our database that provides scalable processing. Now, the models which we use come from two sources currently. One is the Bhashini source. The Bhashini models give you access to all the Indian language models that are presently developed under the government of India's initiative called India AI initiative. And whatever models that have been made open source and made available in the Hugging Face Hub are also then called in through our app, nothing to code there, to use along with your personal API keys, especially for Hugging Face, a personal API key is required to use those models. It's basically a GPU inference pool, and so we have so what happens is that throughout the process where the model infers your data, that is, a model looks into your data and makes it into a transcription text or a translation. What we do is we only send small chunks across. Those small chunks are basically queued in a long list for the models to process. That is, a GPU is there, and then there are multiple small chunks. Maybe 20 seconds is probably the maximum that any model would allow, not more than that. Now, these 20 seconds do not go in the same order as our audios or as our text. They go in random orders, and then they are randomly queued with all other jobs that are there. So at the model end or at the server end where the GPU is running, there is no way actually to reconstruct the whole file that we are sending. So the model, when they process the files, they process bits and pieces of the files, that to a 20-second level maximum, and those necessarily can only be logged and never be reconstructed at all, because the rate at which the model processes data is too heavy for it to reconstruct any of the data after you give. So models then necessarily don't know your data. So models don't know your data. Models only know the acoustic signals that go from the data. So in that sense, they're completely private and secure. So people don't listen to your audios. The servers don't listen to your audios. That's what I'm trying to tell you there. Secondly, the first app that I'm going to introduce is Ateco. It's an integrated data collection platform. It's multi-format support. You can collect audio, video, image, text responses within a single platform, and accommodate diverse data collection methods across languages. So you can give a text as a prompt and get an audio or a video as a response. You can get a video as a prompt and get a text as a response. So all these four combinations are possible, both as a prompt and as a response. And for one prompt, I can have multiple responses as well. So what you're seeing here is the most famous Bowpet kit developed at Max Planck. Now we can implement this instead of a card like this through the app. Multiple response collection, as I already told you. So a sort of a dictionary could be built within the app itself. So you collect a word, you collect its example usage, you collect its example sentence, you collect its pronunciation, you collect its picture if there are any. So all this thing can be recorded within one prompt. So that's what we call when we say multiple response collections, and it works offline. So in the sense that if someone syncs the task, and if they go offline, the task is still available for you to access, complete, and once you're on back into a network zone, you can upload the task into your server, into the server, and then the researcher can download it at their end. So one crucial thing that it helps is that in remote conditions, it helps you collect data, and it also helps you collate data much easily than the rest of our manual collation task. With more and more as our phones get more sophisticated, we know today that our phones can also record very sophisticated audios. So probably we'll move towards the era where dedicated or recording equipment is not necessary. Now, the data that is collected from Ateco is also presented in a structured format along with the data and the metadata. Now, that data could also be brought into our Matra Lab feature. Now, the Matra Lab is basically a project management tool with a data management tool with AI-powered solutions for transcription and translation wherever possible. That is, as Ritesh pointed out, only 15% of the world's languages have models. So for those that don't have a model, probably we can train one, but as far as possible, these are the models that are already available. Those can be summoned and then you can do. So it helps you organize. There's an AI integration along with it for ASR and mission translation, and it also helps glossing. So starting from data collection to glossing, we have a whole pipeline that could be done within the live suite. Then there is a timeline editor, so you can see it for timeline annotations. You can use this to do it. So what you see on the screen towards your left is basically a chunk of audio that has been segmented, and then I can add those transcriptions and translations there. So what you're seeing here is I've added transcription in multiple scripts. So I can have multiple tiers added. I can also annotate for gesture. I can add another extra tier there. I can also do other forms of labeling. If you're interested in, let's say, content analysis, that could also be done here. Now, in addition to this, as we pointed out, all the AI system is human in the loop system. That is, the AI processes it, and you have to check whether it is right or wrong. So as we pointed out before to you, the range of the AI is somewhere between 0.12 word error rate to all the way to 139 words error rate. So that depends on the context that you're using, context of the recording, the people who are speaking, and also the quality of the recording as such. So we are not claiming that that these talks are completely, these AI models are completely error-free. Hence, what we have also introduced is a system where you can verify. So the text box that you see, those can be actually are editable text boxes, and you can correct those and you can save them before you run a translation task. So that was the overall feature. Now, but again, I'll go back into the much more nuanced ones. So data organization. So the data organization happens at two levels. Now, each data could be organized at a speaker level. So we can input speaker metadata. We could have complex speaker metadata like the participant metadata, like the CMDI metadata schema. That are all the metadata schemas are configurable, and we could help you do it. Secondly, the collections could be organized into logical groups based on keywords and other metadata tags. Once you have put those keywords and metadata tags while uploading, while giving the participant information and uploading the data, what we can do is also filter those data as per your requirement. So if someone is looking at a cross-linguistic corpus of speech from 3-year-old, I could go ahead, search, select age as one of the parameters, and I could look for all the 3-year-old. So that sort of a data filtering facility is also available, and also sorting facilities available. Next is we understand that the modern research, especially within documentation, or we know that it applies for psycholinguistics and acquisition research, that it is highly collaborative, that a team of experts come together and do various tasks within these on the files that have been recorded. So to enable that and to make it seamless, what we have done is that we have given a collaboration at the level of a particular file. So you can have access restrictions or access levels at the level of a file, or also at the level of an annotation. So all those files can be shared, and also the annotations can be shared. So I can have a checker reviewer system. So create a reviewer system too. So for example, if I created the annotations, I can share my annotations along with the audio to Ritesh and ask him to review it. Now, when I share, I can also ensure that that the reviewer can only edit. They can't add new segments to it, or they can't download the whole file that I've added. So what we have done is that layered access levels have been built into it. All the projects can be shared. I told you, we can share it at the project level. I can share it at the file level. I can share it at the annotation level. So I can also give you limited time. I can also limit it by time. So all these facilities are already possible by just clicking on share. Now you can also update, or you can also remove someone's specific shares that you already made. So all that is also possible. So an app like Elan, if you're going to use it, what you're going to do is that you're going to transcribe it in your computer, and then you're going to bundle the transcription file and send it across, and then someone else is going to check them, and then they're probably going to overwrite what you've done. Now, such sorts of logging is not possible in these softwares, or even if they are possible, they're very difficult to implement. So what we try to do is that we clearly show you who has changed what, and and what have those changes been, so that all those things can be tracked at your end. So that is the access and share facility. So the other facility that we have is a range of downloads that are possible. As I told you, that we can include several tiers into one particular segment. Now you can select which tier to download, and you can uh, click and choose the the format in which you want to download. Now, so that it is a time-based selection. The download is at the time-based selection. User-based selection can also be done. I can only download the data that Ritesh reviewed and not what I uh, transcribe, right? And then I can anonymize what I'm downloading. So there is a possibility to anonymize all the data at the level of download during downloading. Or I could also filter my downloads and filter my files and download accordingly. And my downloads are possible in multiple formats: text grids, chat, JSON, Excel, LaTeX, CSV. We are also integrating EAF into it. And we already have a chat setting where you can configure the chat transcript. You can configure a transcript to be downloaded into a chat model as well. So these are the range of features that we have that could be used to download the data. So as I pointed out, what we are presenting is an end-to-end model, sort of an end-to-end research flow, starting from multimodal data collection to starting at segmentation using MatraLab, transcription within the MatraLab, and also complex layers of annotation. As I pointed out, transcription and glossing are one layer of annotation, but I can also build on several aspects of labeling, like we could do in Prath or in Elan, add more uh, tiers to the data. So, and then I can also export them in multiple formats, and we are constantly upgrading the formats as per user requirements too. So we have added chat because someone is interested in doing language education data. So we would be adding Elan as someone is interested in language documentation. So we are adding those as and when we require. Now, what I'm going to show to you is how the system performs, not starting from Ateco, but focusing only on MatraLab. So I'm going to show you two small videos. So, and I'll speak along with it as it functions. So here it is. So what you're seeing is MatraLab functioning now. So I hope you can see my full screen. Here, we are creating a new speaker metadata. Now, as I pointed out to you, we could create metadata schemas as per your requirement. This is a metadata schema that we added for our requirement, and then we are just creating data. So these are the metadata fields that we have created. I can say them, not all are necessary or mandatory fields. Now I'm uploading data. It's just a click and drop function, added data. I could also add item level metadata information. Again, I could have item level descriptive informations in the metadata column, in the metadata tab there, and then I could also have other advanced audio level features also specified in these things. Now, as I pointed out to you, within one project, we can have multiple speakers and we can have multiple speakers, each speaker's multiple files. So I could have one file which is about their life history or the linguistic history. And then I could have another file where they are, sorry, the upload is taking a bit of a time, where I am doing some sort of a ethnographic interview with them, right? So once you see the tick mark, the file is uploaded. Now the video is there and the audio, its corresponding audio is shown as a waveform for us. We can simply drag and expand it like we do in Prath. It's just a timeline editor, so you can simply select, drag, and a segment is created. Once a segment is created, just hit save, the yellow button on the top, so that the boundaries are saved. Now we are calling upon AI to help us out in transcribing it. So the few things that you have to select here, that you need to know which hub that you're using. There's no audio in the data, so I'm just speaking over. So the few things that you can select is what models hub you are going to use to transcribe. You can use either Bhashini UCLA, ULCA, or the Hugging Face. If you have used the Hugging Face, as Ritesh pointed out and as pointed out before, you need to use your personal Hugging Face key. It is for free and it is available for everyone. And once I have selected that, I need to select the model that I need to use. So this is a Hindi model. So we select a Hindi model. And then we also decide, we also need to be very sure that the right audio language and the required scripts are selected. So you can see in the side here that it is still blank. We are going to hit transcribe. It takes a few seconds based on the length of the audio. And here it is in IPA and in the local language, and in the local script, that is Devanagari in Hindi here. Similarly, you can correct those. We can see that a question mark was added. We saved them. Now we can translate them, just sync translation. So whatever corrections I did would be fixed there. So I can do, if I correct my Hindi, my IPA will also be corrected. If I correct my IPA, my Hindi will also be corrected. So either of this correction is possible. Once my transcription is validated, I move to translation, where what I do here is I again call upon a machine translation model to help me select. So select the right models. We are doing the Bhashini Hindi English model, which is going to help us translate it. So we selected the source language and its script, Hindi in Devanagari. So it is going to target the Hindi in Devanagari and translate to English and produce me the translations in Latin script. Who is this brother? So that's how quick it is. So some of the tasks can be quickly made, could be quickly done. We could also do interlinear gloss, but I'm skipping it for now, for the sake of the time. Back to presentation. I hope you can see my screen again. Sorry. So what you saw is an example of how you could process data with Matra Lab. Now, all the features that we spoke to you are already there. Now, we also told you in the beginning of the speech that a lot of models are not available. Very few models are available across the world. And what we wanted to do is also fine tune some of the models that we already have. So one thing that we have done is we took Hugging Face auto train facility, configured it to for the first time to train speech data, because this is something that no one has done so far. So we have configured our auto train to work on speech data building, speech data model building, and fine tuning as well. Now, this helps us give data curation, documentation. So auto train has all these things. There is a UI wizard that helps you prepare the data, validate the data, and select it. There's also a documentation that generates the models and ensures reproducibility and transparency. We clearly tell you how the model is created. You can do it two ways. We can have an in-house GPU and we can train the model within your own IT infrastructure. Or if you don't have one, you can also rely upon GPUs from outside. So that is also possible. Now it's one-click fine-tuning with base models, epochs, and learning rates. Now, as Ritesh already pointed out, fine-tunings would still require you to know a bit about what are these terms are and how to use those terms. So there are now clear protocols like a scientific research here, but this is sort of an art that people are doing and learning as they go. Now, one of the things that we recommend people is that Hugging Face offers GPU for free for some people. So if you have Hugging Face Pro or an enterprise account, you can use their GPUs as well. Now, this is the Hugging Face interface. I could show you a video of this rather than this. So this shows you how the whole model fine tuning is. So what we are trying to do is we are trying to fine tune speech recognition model. We are taking Facebook's wave to wake model, and then we are trying to run it on the data set that we have at our end. It's just an Excel file, CSV file. That's what. Start training. Done. So there are the auto train facility. I'll just go back once up. So the auto train facility has 3 sections here. To the left are the tasks that you have to select. As I pointed out to you, automatic speech recognition tasks were not there. We have built that out, and then that's what we have also contributed to the Hugging Face groups as well. You can select the hardware. You need to select the basic parameters on which that you want to run it. At the middle, you see what you need to select is the model that you're going to fine tune and the data set where it is available. That's all it is. Once you have done that, if you want to play around with the parameters, please do and start training. Once you have started training, if your training is successful, you will get a message that tells that the training is successful. Now, as I pointed out to you, that there are much more complex parameters available. Once you enable the this is just once you enable the advanced view in the parameter selection, you could see all the advanced features that are already available, which you can change and experiment with to fine tune your models. So with that, our Hugging Phase 1 is done. So we are just going back. So what we are trying to build here is an ethical and an responsible AI implementation. Now, we wanted to start from the beginning when you want to use AI models, be transparent, fair, and ensure that our data is secure, and also anonymize wherever required. Now, throughout our base, you can see that all the steps we are ensuring that there is complete ethical standards and responsible AI measures are put in place. At the data security level, while our platform can also host data, we are moving towards becoming a full GDPR compliant platform. We are almost there. There are just a few audit trials that we need to complete for us to become a GDPR platform. So I'll just quickly wrap through this. What are the future directions? We are looking to build a community of researchers who are interested in Indian languages and try and develop models and validate models that have been developed. We are also offering training programs where computational tools, linguistic research methods, and linguistic communities can be bridged. Like create a language technology truly for all communities, not just for the 15% of the languages that are spoken. An innovative pipeline, as I pointed out, ASR model within the auto train facility is the first to be done. We're the first to do it, and we want to ensure that it is accessible and inclusive for all groups. When we say group, when I say all groups, we say language and research communities equally. So that's it. This is our team, and for any information, you can contact us here. You can, if you're interested in our app, you can Google, you can go to GitHub and pull it out and then try to build it at your own end. This is all open source that we do. You can also write to us. Now, I think we can open for questions. Open for questions and discussions.
Hi. Hi, yes. Thanks so much, Ritesh, Karthik, for that wonderful talk. Lots that we got to learn. I'm going to open the floor for questions. You can raise your hand or put your question down in the comment box. Okay, while everyone's planning to raise their hand. Let me read out a question that was in the comment box, I think. Right.
No, those are
Someone
addressed, right?
asked for, yes, someone had asked for access to papers or publications related to the project, and Ritesh has provided the link to that in the comment box. So in case you are interested. Right, we wait a bit for someone, if someone has a question. All right, if nobody has a question, then I will ask something that struck me when I saw the data from the 2-year-old versus the 5-year-old. Yes, okay, Lilia also has a question. Lilia is hosting with me. So I will go ahead and put my question and then read out Lilia's question. So about the 2-year-olds and the 5-year-olds, so there seems to be hope for the 5-year-olds. The 2-year-olds, it looks a little scary. But if there were a conversation between an adult and a child, which is also a kind of data we collect, right? What would the model do? Would it be okay with the parts where the adult is speaking and sort of mess up where the child is speaking?
Yes, that's what we would expect, Yangshan. So if you notice, we could make those segments, right? So uh, it will get all the adult segments correct. Most of the adult segments would be correctly marked. It might miss some of the child segments, and while transcribing the adult segments is going to be, much better at par with the numbers that we showed. For the children, again, it would be, it may not be as good as the adult ones. There could be other factors at play as well. So for example, uh, the so the volume of the audio or the loudness of the child speech itself, that might also have some role to play in this. And uh, there could be also how much of overlap is there, things like that, how much of noise is there in the background. So all of those will play some role in how the model ultimately performs. But it should still get, unless you're a 2-year-old working with 2-year-old child data, then probably, yeah, it looks really scary. But otherwise, you should get your on an average 70 to 80% of your transcription work done
Right.
by the model. Yeah.
At least for the older kids, yes, it seems like we have a lot of hope. So essentially, if when the data is multi-speaker, does that mean that the model that it's going to access to transcribe it or whatever, essentially, would be the adult one for the adult part and the child one for the child part? Would that be able to do it? I don't know if I make sense.
Yeah, there's no model for the child part as of now. But if
Right.
you
I mean, if
did
we were
have,
to have one, if we were to say
yeah,
train,
then yeah, then
manually
you could,
transcribe and.
yes, then you could use separate models for separate segments.
Okay, that's great. I'm going to quickly read out Lilia's question. Are there plans to integrate other modalities such as gesture?
I just want one more. If you could rephrase the question or give us much more clarity there. Do you want recognition of the gesture? Do you want like automatic recognition of the gestures, or do you want labeling for gestures, like a tier where you can annotate for gestures? If we want a tier to annotate for gestures, yes, you can already do.
Okay, yes, because glossing is possible, right? So,
yeah, no, I could do it along with the timeline segment as well. If a video is going, I could timeline and I could add another tier to the tier. So that could work, but automatic recognition systems are not yet in place.
All right. We have Alejandra who has her hand raised. Go ahead, ask your question.
Thank you. Thank you very much. And thank you also very much for the presentation. So I have two questions that are actually related, the one and the other. So the first one is, maybe I missed that part of the presentation, but I wanted to ask if it is possible to fine-tune not only the speech recognition models, but also the translation and the glossing models, if that's also a possibility. And okay, and maybe the second one, I will put it now because it's related. How many data do you like should a linguist put in order to really see an improvement in the fine tuning? Like how many hours of speech and how many sentences and right, for the different models?
Yeah, you could definitely fine tune other. So see, translation is a possible. Translation is already there in the interface. Glossing is so for glossing, what we need is a more detailed data. I mean, also that you may not need to you may not be able to fine tune using the same interface, the auto train interface. We're trying to work on that. The reason being that the ASR and machine translation models, they they're generally what's called neural network models. So that's a different, more recent technology. Glossing, on the other hand, doesn't require GPUs and all of those technologies. So uh, we could build that's not there as of now, fine-tuning glossing, but this is something that we're working on, that's in the pipeline. So maybe in the next couple of months, or maybe in 4 months, definitely by the end of this year, we'll have you'll be able to fine-tune the glossing models as um okay. And how much data is very experimental. So, and I mean, so it could only be empirically uh, understood how much data is needed for fine-tuning the models. But say, if you have 2 hours of data, for example, right? So, uh, 2 hours of 2-year-old child's data, and then you use that to fine-tune the existing model. That in itself will lead to an improvement in the model's performance. So the process is kind of iterative, improving the model, and you stop when you think that it's sufficient. So it might just be the case that the specific model that you're fine tuning, it might just improve with, say, 5 hours of data, and you may not need to fine tune it further. But there could be other models or other kinds of data where you may need 10 hours, 15 hours of data. But having said that, it's never going to be huge amounts of it. It's not going to be thousands of hours of data to fine tune it. So the amount of data to fine tune and improve the model should not go beyond 40 to 50 hours of data. And within that range, any model should start working well for any domain or any kind of data.
Okay, thank you.
All right, looks like we don't have any more questions. Just check the chat.
I have one question.
Okay. All right, please go ahead. Yes.
Oh, yeah, the question is regarding the dictionary making. If I am working on a vernacular language, if let's say ethnobotical terminology, I am adding, but does it like automatic to translate in like scientific name of the plants or seeds, weeds?
Pratik, if you can give it to us in the common Hindi
Okay,
gloss.
let's say if I have collected the word like dudhia. Dudhia is a term for one flower. Okay, if I am transcribed and added that picture, could it like translate in like scientific name of the plants also?
No, this app can't do it,
Not in
but I could help
okay.
you with something called Snapseed. Look it
Okay.
up online. It's a Google's app called Snapseed, where you upload a photo and it tells you the name of the plant.
Snapseed.
Yeah. But that is not within our domain. That requires a lot of other data to be linked. But you could use our tool to build cross-linguistically linked open data of ethnobotanical names. That you could do. We are working with some indigenous communities to do that in the Nilgiris, so that you could do with us too.
Okay.
You could do that within the app. That's possible. It could be linked with what is called DBpedia or something like that. DBpedia's list of scientific names.
Okay. Thank you.
Before you close, that's our email ID. For any questions or queries, please do write to us.
Karthik, Ritesh, thank you again very much for giving us acquisitionists a talk from your side of the world where there's so much happening. And let me announce the next talk we have, the next seminar in 3 weeks this time. Charles Saliba will be speaking to us on Malta, its socio-linguistic landscape and the methodology behind the Maltese as a foreign language for junior series. You will receive a notification if you are on the LangVIEW mailing list. And if you're not, you can always ask us to put you on the mailing list and you will start receiving intimations. We have also been putting the news of the seminars on Linguist List. So if you keep track of that, then you would receive it that way as well. All right. Thank you again very much. And I'm going to close the session now. Thank you.
Thank you.